This question reads, Figure 5.1 shows a ray of red light passing through a semicircular glass block. So we have a single color ray of light coming. It enters a semicircular glass block, and at this point, it continues its path straight without any deviation. Because at this point, when we draw the normal over here, then the angle between the incident ray and the normal would be 0 degrees. So there would not be any deviation when the ray of light is coming from air and entering into more dense medium, because the angle of incidence is 0 degree. So it continues its path straight and then strikes this boundary. And now we can see that two angles are made over here. This dotted line passing through the point of incidence, it is called the normal. And two angles. First angle is the angle made by the incident ray with the normal. It is indicated as P. And the second angle, which is made by the incident ray with the boundary, is given to be as Q. Now, when the ray moves in air, since it is coming from a denser medium and enters in a less dense medium, so its speed increases and it moves or bends away from the normal. Again, two angles, R is given and S is given. R is being made with the normal, so it is the angle of refraction, and S is the other angle which is being made with the boundary of the two mediums. Now the question reads, state the term for the dotted line shown in figure 5.1. The particular term for this line is, it is a normal. State which angle PQR or S is the angle of incidence for the ray of red light. So as we can see in the figure, the angle made with the normal by the incident ray is P. So P is going to be the angle of incidence. State which angle PQR or S is the angle of refraction. Again, the angle of refraction is R. So I'm writing R over here. State what happens to the speed of red light as it enters the semicircular glass block from the air. Semicircular glass block is a more dense medium. So whenever a ray of light enters in a more dense medium, its speed decreases. And in the opposite case, when the ray of light is entering into air from the semicircular glass block, the speed is going to increase. The next part reads, Figure 5.2 shows the path of a ray of light entering a semicircular glass block. The critical angle for the glass block is 42 degrees. Now this information is very important. The critical angle is the angle at which the angle of refraction becomes 90 degree. And whenever the angle of incidence is greater than this value or the critical angle, then a particular phenomena occurs which is called total internal reflection. So it means that if angle of incidence is going to be greater than 42 degrees, then the ray is not going to refract. It would undergo total internal reflection. And for all the angles which are below 42 degrees, all the incidence angles, then the refraction is going to happen. On figure 5.2, continue the path of the ray, show clearly its direction on leaving the glass block. Now this ray has an angle of incidence equal to 62 degree. And we know that 62 degree is the angle which is greater than the critical angle. So it is not going to refract, rather it would undergo total internal reflection over here. Now, after striking this point, the ray would be internally reflected. And whenever the reflection happens, it follows the laws of reflection. And the law of reflection tells us that the angle of reflection would be equal to the angle of incidence. Since the ray was incidenced at an angle of 62, so it would be reflected at the same angle of 62 degree over here. And when the ray of light, after being reflected at 62, reaches the boundary here, it will not show any bending and it will continue its path straight. I'm going to show this by making a drawing over here. By using the protector, we have to set the angle of 62, and then we would make this ray and make an arrow over here, one here, and it is better to show this angle that the angle made over here would also be equal to 62 degree. So this drawing is going to earn us 2 marks if it is shown to be totally internally reflected, and when it exits the glass block, it does not deviate, it continues its path straight. The next part reads, a ray of white light passes through two prisms as shown in the figure 5.3. So ray of white light is coming, and we know that white light consists of 7 colors, which are red, orange, yellow, green, blue, indigo, and violet. We can remember them using the phrase Roy G Biff. Now, when the white light strikes this surface, it follows its path undeflected, and the reason being the angle with the normal is 0 degree. Now, when it strikes this surface, the angle of incidence here is greater than the critical angle for the prism. So total internal reflection occurs, and it is reflected within the prism and follows this path. Again, it follows a path undeflected from this surface of the prism, and then it strikes this point of the second prism. And now we can see that it is broken into its constituent colors here, and further refraction, on the further refraction, the spectrum widens up. So refraction is happening here, refraction is happening here. Refraction is the bending of light and change in the direction of light because of the change in speed when it enters from one medium to another medium. So refraction is happening here and another refraction is happening here. Similarly, the light is also being broken into its constituent color at first refraction and in the second refraction too. Draw one line to indicate the letter for each position to the correct effect at that position. Now this is the point D which is being shown here, and we can see that total internal reflection is happening at point D. So we would be making a line connecting D with total internal reflection. Now at point E, we are given with three options: reflection, dispersion, and diffraction. Reflection is not happening at E, we can see. Diffraction is not possible here. That happens only when the ray of light is passed through a narrow slit. So the only option, correct option out of the given option is dispersion, that the light is dispersed and broken into its constituent colors at E. So we would be making a line and joining E with dispersion out of the given options. Now the last one is F. There are three options: a red, green, and blue light only produced, white light produced, spectrum of visible light produced. So at F, again, we would be having a spectrum, the complete spectrum starting from red, ending at violet. So the correct option here is a spectrum of visible light is produced. So F would be joined to this box. So by joining each point or the position correctly with the effect, we are going to earn 1 mark. So it is a total 3 mark question or the part in this question.